Environment, Health, Safety in Semiconductor Manufacturing, Part 2. In the semiconductor industry, a strong focus on environment, health, and safety, commonly referred to as EHS, is critical to ensuring not just business performance, but also human and environmental well-being. This commitment centers on protecting people, the planet, and performance. Environmental responsibility includes implementing sustainable practices to reduce waste, conserve energy, and minimize chemical emissions. Clean rooms and advanced filtration systems are just one way to safeguard air quality and limit environmental impact. Health focuses on worker wellness, including ergonomics, chemical exposure prevention, mental health support, and routine health checks. Employees are the core of this industry, and their well-being drives operational success. Safety involves robust risk management systems, from emergency response planning to equipment safety protocols and hazard identification. Together, these pillars form the foundation of a responsible, high-tech manufacturing culture that prioritizes long-term sustainability and the protection of all stakeholders. Shaping the next generation of EHS excellence. To shape the next generation of environment, health, and safety, or EHS, excellence in semiconductor manufacturing, 4 strategic pillars are guiding the future. First, the 2030 vision target represents the long-term roadmap, aiming for transformative, measurable safety outcomes by the end of this decade. Central to this vision is the zero harm goal, which sets an uncompromising benchmark: no injuries, no incidents, and no excuses. This zero-tolerance objective aims to embed safety into every aspect of operations. Next, smart safety through AI technologies is revolutionizing hazard prediction and real-time decision-making. Artificial intelligence allows for proactive risk management and predictive interventions. Lastly, achieving net zero, or carbon neutrality, is a key environmental goal that supports global sustainability. Together, these priorities define a forward-thinking, data-driven, and people-focused approach to EHS advancement in semiconductor fabs. Emerging trends. Technology revolution. Emerging trends in EHS are being driven by a technology revolution. AI and machine learning are increasingly used for predictive safety, identifying risks before incidents occur. These algorithms analyze vast datasets, flag anomalies, and suggest preventive actions. IoT sensors add another layer, enabling real-time monitoring of environmental conditions, equipment status, and personnel exposure. Digital twins, virtual models of physical systems, help in simulating risks, stress testing scenarios, and optimizing safety procedures without disrupting actual operations. Automated response systems further enhance safety by enabling rapid shutdowns, alarms, or rerouting based on sensor feedback. Another innovation is smart PPE, personal protective equipment integrated with biometric tracking to monitor vital signs, fatigue, and exposure. This gear allows for immediate alerts and interventions. Altogether, these technologies contribute to a smarter, faster, and more responsive EHS ecosystem that protects workers while optimizing performance. Future challenges. Preparing for tomorrow. The future presents complex EHS challenges that require innovative strategies. One of the foremost is the safe assessment of advanced materials, many of which have unknown toxicological profiles or reactive behaviors. As semiconductor processes push into nanoscale domains, new health and safety risks emerge, including nanoparticle exposure and ultrafine contamination. Scaling production while ensuring worker and environmental safety becomes increasingly difficult as manufacturing speeds and complexity grow. Additionally, coordinating EHS efforts across the global supply chain is critical, especially when partners and suppliers vary widely in regulations, culture, and capability. Lastly, workforce evolution is a major concern. As automation and digitalization reshape jobs, ongoing training must ensure employees remain safety literate and technologically proficient. Addressing these interconnected challenges requires foresight, investment, and collaboration across departments, companies, and borders to maintain a culture of safety and sustainability in tomorrow's fabs. Sustainability, green manufacturing. Sustainability is a core pillar in advancing EHS excellence in semiconductor manufacturing. The industry is actively transitioning to renewable energy sources, reducing reliance on fossil fuels and cutting greenhouse gas emissions. Water conservation and recycling are also vital, especially in a water-intensive sector. Facilities are implementing closed-loop systems to reclaim and reuse water. Green chemistry is another priority, replacing hazardous substances with environmentally friendly alternatives to protect both workers and the environment. Circular economy principles promote waste reduction by encouraging reuse, recycling, and the design of products for longevity. Lastly, life cycle assessment integration ensures that environmental impacts are evaluated from raw material extraction to end-of-life disposal. Together, these strategies enable a shift toward carbon neutrality while supporting safe, sustainable innovation. Green manufacturing isn't just ethical, it's essential to long-term industry viability and community trust. Path forward, strategic roadmap. The path forward for EHS in semiconductor manufacturing is rooted in collaboration, innovation, and preparedness. Industry collaboration on global EHS standards ensures consistent practices and safety expectations across companies and geographies. Research partnerships with academia provide the scientific foundation for smarter safety systems, materials innovation, and risk modeling. Regulatory engagement is crucial to shaping policies that are both forward-looking and grounded in real-world conditions. This ensures readiness for emerging regulations and builds trust with governments and communities. Talent development programs help equip the current and next generation of professionals with the technical and safety skills needed in a rapidly evolving workplace. Finally, innovation ecosystems foster environments where startups, universities, and corporations co-develop solutions for shared challenges. This strategic roadmap builds resilience, accelerates progress, and unites stakeholders toward a common goal: achieving excellence in EHS through a proactive and collaborative approach. Key takeaways: EHS in semiconductor manufacturing. There are 5 essential takeaways for understanding the role of EHS in semiconductor manufacturing. First, EHS is critical. Without rigorous safety and environmental systems, semiconductor operations cannot thrive. Worker protection, equipment reliability, and regulatory compliance all depend on strong EHS foundations. Second, people come first. Every decision should prioritize worker safety, from process design to emergency planning. Third, innovation is a key enabler. Advanced technologies, from AI to smart sensors, support safer, faster, and more informed responses to risk. Fourth, collaboration is indispensable. Cross-industry cooperation, shared standards, and aligned goals ensure that best practices can scale globally. Fifth, EHS is a continuous journey. Excellence isn't a destination. It's an ongoing commitment to evaluate, improve, and evolve. As a final message, the future is bright. Through sustained innovation and commitment, the semiconductor industry can reach unprecedented levels of EHS performance while powering the technologies that define our future.